All right. Well, good afternoon, ladies and gentlemen. Thank you all so much for being here with us this afternoon. On behalf of AUVSI, I'm very pleased to welcome you to today's webinar, Agriculture Applications, Imaging, Spraying, Spreading, and Part 137 Certification. My name is Shannon Walker. I'm the Director of Programs here at AUVSI. Before we get started, we have a couple of housekeeping items that we always like to go over. So as always, our participant lines will remain muted throughout the webinar. We are recording this program, so you can expect to receive that viewing link along with a copy of the slide deck to be emailed out within the next week. All of our webinars are on AUVSI's Learning and Engagement platform, AVL. If you are listening to our webinar today and you need any technical assistance, please send a note to the webinar leader using the chat button at the bottom of your screen. After our presentation today, we are going to open up this session for Q&A. So attendees, you are welcome to and encouraged to submit those questions at any time throughout the webinar using the Q&A button at the bottom of your screen. We will be saving the questions to be answered towards the end of the presentation, and it's worth noting that the Q&A button is a different button than the chat, so just make sure you're submitting all those content questions using the Q&A button, which is right next to the chat. All right, well, let's go ahead and get started. We would really like to thank Embry-Riddle Aeronautical University for their support of today's webinar. And we are excited to welcome back an excellent speaker with us today, Dr. David Thirtyacre. He is the chair and chief pilot for the Department of Flight at Embry-Riddle's worldwide campus. His research expertise is focused on the use of UAS in air combat, virtual reality flight simulation, and agricultural and environmental applications of SUAS. He is an AUVSI Trusted Operator Level 3 Remote Pilot Instructor and an FAA Certified Flight Instructor. So we are certainly in great hands to cover this topic of conversation today. So with that, 30, I will hand it over to you.
Thanks, Shannon. I appreciate the introduction, and it's great to be here. It's always fun to do something with AUVSI. So we've been engaged with AUVSI since I think about the beginning back there, and it's just been a great relationship. So thanks to you and your team. So yeah, today we got there's lots of stuff on the slide here on the title slide. Yeah, we're going to talk about ag ops, imaging, spraying, spreading, and 137 certification. So each one of these is probably a class in itself. Well, it is a class in itself, but we're going to cover a lot of this today. So for those of you jumping in here who are experts in the industry, there's spots in here where we're just going to barely touch some stuff. You'd probably wish there was more. And for those of you who are brand new to this, it's probably gonna be more of the fire hose type thing. So with lots of new things coming up. But we'll dive into this and talk about quite a few of the different areas in here. By the way, one of the reasons, actually the reason why I really wanted to do this webinar on ag ops was because of the change that the FAA made back in August of 23, where they basically streamline the process to become a Part 137 operator for UAS operators. And this is a huge deal because we had been waiting, Embry-Riddle had been waiting, we'd been in the queue for 2 years, and it was looking like it was going to be one more year before we were able to get the FAA FSDO office to come down and certify us. So good on the FAA. I mean, it's a great job. They recognize the issues and they shrunk it down. So now getting Part 137 certified is not something that is 2 to 3 years away and an incredible amount of pain. There is some pain involved in it still, and we'll talk about all that. But again, this is now opened up finally to be able to get something done in this area. So what we're going to take a look at here is I'm just going to dive into the background here just for a second to some of the information. We'll talk about imaging. I'll talk about aircraft a little bit, sensors, but mainly talking about kind of products and that kind of thing that you're coming up with. We'll talk about the aerial application, specifically aircraft. I want to get into the flight planning. I want to talk about, again, the spray and seating part of that. And then we'll spend probably about the last 10 minutes, maybe a little bit more, talking about Part 137 certification, how to get the waivers for 107 and 137, the process involved in all that. And then don't forget about the state and local pieces to this too, because sometimes that is more daunting than the federal side of it. So you got to watch out for that. This image on the right, it was a recent project I did down in Mossy Rock, Washington. This is a hayfield, and the farmer wanted to put down some clover seed. So this is actually seeding. You can see down on the drone there, there's actually a hopper in there that's holding seed in this case. But what I want to show in this picture is really the trees down there, because every time I've gone out to do an operation, no matter where it is, a matter of fact, up on the hill, you can kind of see in the background, there's some Christmas trees up there. Every time I go out to a place to do some sort of operation under 137, there's something I wasn't expecting. In this case, I did not see the trees in the middle of the pasture when I was planning this, and that changes things. So there's a lot goes on to flight plan and everything else as far as the 137 and actual application goes, and we're going to get into a little bit of that. By the way, you can see on top of the drone there, there's a little square box on there, which is our RID module for this. So we are in compliance with RID now that it's the waiver period is pretty much done now from the waiver, not the waiver, but the limited enforcement, I should say, that the FAA has been doing. So anyway, go RID. All right, so let's take a look at some background. You can see over on the right side here, this was a study that AUVSI did back in 2013, taking a look at what they thought the economic impact was going to be using UAS. And you can see it hasn't quite panned out like that. And there's several good reasons for it. First of all, the entry getting into Part 137 legally it has been almost insurmountable until now. Until August. So that was a big factor. And the other one was just the type of operations that are done in the U.S. compared to where a lot of this information came from, which is over in Asia. The use cases are much different in the two places. So what we've actually seen, I think, on this is kind of the opposite here. We can probably throw us upside down. Egg's probably the green down there. Public safety is actually the green is probably less than that. And then public safety, and then other is probably what we're seeing in red now. So again, the crystal ball isn't always right is the point here, but I think we're finally to a point where things are going to start moving forward, and we're going to start to see a lot more operations on the agricultural side here coming up. So background-wise, let's talk about barriers to entry. As far as remote sensing, we're talking about hardware costs anywhere between about 5 to 15,000, and they can go, as anybody knows who's been in this industry for very long, you can go well above that. You can buy all sorts of stuff, just a matter of whether or not you want to actually pencil out or not at the end of it. Hardware costs for the cameras for the aircraft, to carry the cameras. And then you also have the software costs. And something not to be forgotten is that in order to really get into what multispectral sensing can do, you have to have that software available that can make the product really a visible product that you can make decisions from. And then the last part of that is the data interpretation knowledge, and that's huge. I did a project, this was probably 8 years ago, with a multispectral sensor from our friends up the road here where I'm at, from MicaSense. And we got done with the whole thing. I literally went out and took, it was for the entire growing season, twice a week. So we're talking, what, in the neighborhood of probably about 60 flights or so. And at the end of the whole thing, the grower, and more importantly, the company, I won't mention who they are, but they're a very large juice maker in the US. And they came back and they said, we really cannot figure out what to do with all this data. And at the end of it, it was like, okay, so we did all this, but we have to have that knowledge on how to interpret it. And that's kind of where we're at right now, because we have all this technology and these cool stuff we can do, but how does that make the farming more efficient in the long run? And that's really what you're here to do. We can make lots of pretty pictures, but if you don't have that interpretation knowledge and understand how that applies to the farm, it's all for naught. All right, so aerial application. Getting into that, hardware cost, again, 15 to about 40,000. Again, it goes well north of 40,000. Some of the smaller aircraft you can get into that are just under 55 pounds. Like the one I had in that last image there. Again, starting out right around 15 grand, and then you can go up to some pretty decent sized ones that are going to be able to hold 20 to 30 liters up at that 40K. But the barrier to entry on the cost, again, is not cheap. The big problem was the Part 137 certification. We'll get into that, and again, we'll talk about that one specifically. And then also keep in mind that if you're really going to do this, you need to get into the greater than 55 pounds, and that's going to require some more waivers to Part 91. And a couple other parts. We'll figure that out in a second. Anyway, and then get into the state and local licenses, which I mentioned is a fairly big deal. Here in the state of Washington, there's about 4 tests that you have to take in order to get your application license here. So there's always pieces and parts to that you have to watch out for. And frankly, those are the ones that people miss, and those are the ones that are probably the most important, because it's how to handle hazardous materials and things like that. All right, so there's a little background. So set up for kind of where we're going here. Let's talk about precision ag here for a second, though. Multispectral sensing on the left here, that image you can see there, that is from Christmas Tree Farm. On the right side of that, on the right side of the left-hand image, you can see their newly planted area, and on the left side of the left image is the mature trees they have over there. We'll take a look again at that here in a little bit. And there's all sorts of things that you can do with images like that. That I think is taken from a Red Edge P, if I'm not mistaken. And in the multispectral side, the irrigation management is one that we immediately go into. Hey, I want to see the crop health and everything, but irrigation management ends up being absolutely huge, especially if you live in an area and the farms are in an area where there is some varying terrain, like where I'm at. Even the flattest farms management, and those are really big. A lot of times you can get that information that you're looking for without even having the multispectral sensors. More of an RGB type of sensor works out really well. Other things you can do with soil analysis, yeah, you can monitor the crop health using some indices. We'll talk about those here in a second. And then we have yield prediction, which depends on what you're talking about. Yield of Christmas trees is pretty easy there on the left side. Yield of smaller berries and things like that can be very problematic. So again, knowing the crop and knowing how that works is really important. Disease detection is a big one, especially up here in the Pacific Northwest, where there's a lot of forestry going on. Being able to follow where the bark beetles, for example, might be going through an area and things like that. Weed detection, and that's one of the images on the left. Again, we'll talk about that there. So for aerial application, yeah, you can basically put anything you want on there. The one that I really didn't even consider, though, is that bottom one, which was seeding. And this is a pretty big one, because it allows you to get an aircraft over in an area and seed specific areas that you normally would have to drive a tractor out into or something like that, and it's going to destroy some of the terrain. So being able to get in there and do seeding area-wise is really important. Matter of fact, we did a lot of spraying in that with our drones, and now they are configured over to use the hopper to spread granules. Ends up being something bigger and more useful in the areas that I'm at up here. So kind of interesting where you end up on some of this. But the bottom line is, this is where we're trying to get to, right? It's not like just doing multispectral. It's not doing just aerial application. We're looking to be able to go out there and find areas that need to be treated, figuring out a prescription for how they're going to be treated, and then doing that in a specific area. And that's what that precision agriculture really is. If you think about it, we're going to observe it, we're going to measure what's going on, and we're going to respond to that area is really what we're trying to do. And there's a couple companies out there. I'm not sure. Yeah, I think Ashley from John Deere is on here. They're doing a lot of cool stuff. Great conversations with her about what they have going on. A lot of it she can't talk about, but really neat things that they're doing as far as precision agriculture and being able to apply some sort of prescription to a certain area instead of going out and just spreading something on an entire field. Matter of fact, a spraying company we were working with down in Texas, who mainly uses helicopters to do their spraying, they were saying that from some of their the companies that they work with, they're seeing about a 40% decrease in the amount of material that has to be applied because of the imaging and the things going on to be, again, that precision agriculture side. So again, lots of interesting things going on in this area, but the whole desire is to take these two areas and mate that imaging and the detection and find out what's going on, be able to marry that with that aerial application and be able to do at least some sort of precise location and treatment for certain things. So again, very interesting. That's where we're trying to get to as far as precision ag. So let's get into some of these cameras and talk a little bit about some of that. So again, I know a lot of you are probably familiar with this. It started out, 10 years ago, there was only a couple companies that did any of that. It's opened up quite a bit now. You can see that DJI Mavic 3 Enterprise there that has the multispectral sensors, the sensor over on the right. But again, concentrating on kind of the big wig around and the one that by the way, I'll probably say this up front here. Embry-Riddle has worked with MicaSense quite a bit. We've also worked with Pix4D a lot. So you're going to see a lot of their products throughout this, since we are a long time consumers of their products and partners with them. But MicaSense has just done an incredible job. A great company to be able to literally, you call up and you can talk to somebody up there, which is just amazing today, about their different sensors. Their sensors, again, generally somewhere between about $5,000 to $10,000 for one of those sensors that they have there. And then again, the Mavic series up there pretty high, and some other companies coming in to have that too. Have that capability as well. If you look down at the chart below, what we're specifically talking about are not huge parts of the spectrum, though. We're talking about fairly small parts of the spectrum, where you can see the blue-green down below, and then you have the red and the red edge, which are absolutely critical for the crop health, because typically crops are going to mature vegetation is going to absorb that red light. Red edge is used more a little bit for the chlorophyll, kind of later in the season type stuff we'll talk about. And then the near infrared is really important too, because typically, again, your vegetation that's healthy in that is going to end up reflecting a lot of the near IR. So because of that, we can sit there and play around with these and make literally different equations, adding and subtracting levels of things in order to get the pictures that we want. Some of these other systems as well. I know the Ultim up here has the infrared sensor on it as well, and that adds quite a bit. So now you have that near infrared, and you also have a far infrared sensor. And that is good for a lot of things as well. So lots of multispectral sensors out there, more coming on to the market. You got to be kind of careful with this, though. There's lots of shiny brochures, as everybody in this industry knows. I typically like to wait a few years and see how things go before we end up investing in them and buying them. And again, that's why we work closely with some of the companies we do, because they have more than the glossy brochure out there. All right, so a big part of this, now you got your images, and that you get into the data analysis software. And I mentioned this is anywhere 1 to 4,000, could be significantly higher than that. You basically pay what you get for in a lot of these areas. These are kind of three of the ones that we use. The one on the left is an older program. I actually don't even think it's available anymore. It's called Atlas. That kind of is what the one in the upper right is now, which is Pix4D Fields, and then down below that is just Pix4D Mapper. So there's lots of different capabilities out there. If we take a look at the one in the upper right, you can remember that, I don't know if you can see my cursor or not, but on the image in the right, on the left side of that, you can see an area that has a lot of yellow. Down below, there's a lot of purple in between the different trees. Again, these are Christmas trees. But as you get up to that upper right, you're starting to see a lot more vegetation. So there's obviously something going on there where they're not getting there. There's a lot more ground cover in that area, probably with a lot more weeds and things like that going on, especially when you see that road. So we probably have an irrigation flowing down into that to make it wetter than they would like it to be in that area. Something else going on in there. But keep in mind, this is all about visualization. Okay, so it's all about being able to visualize the health and the status of the crops, and the farmer understanding what they need to do to fix that. So in this case, I'm using it's called the Glow color palette, but it really makes it all pop. And there's all sorts of other color palettes. You can come up with your own. You can do whatever you want. But I tend to like to try to take mine and make it into what pops. And you can also see over here on the right-hand side of that right-hand diagram, you also have the ability to manipulate everything you're looking at. So this is actually the very index here, but you can take a look at the right side over there. You can see how you can manipulate what it is you're actually looking for, isolating certain parts of that region. And then the neat thing about this program too, with fields, is that I can go through and I can have all my fields mapped, and I can look at them over time. I can compare them, and I can do lots of neat stuff with that. So the one down below is Pix4D Mapper, which is just a great starter one to get into, because you can generate all the indices that you want. You can create your own, by the way, in both of these, you can create your own indices, which is what we have our students do. We have them use some of the standard ones out there, then we make them create their own based on what they're seeing in the imagery and what the objective is of the assignment. So we have them doing a lot of equation manipulation to develop their own type of indice they might be looking for. All right, so what are some of those? I just threw a few up there just for those who aren't familiar with this. There's literally, you saw on that last slide, I think there was what there's over there on that upper right image. There's probably at least 10 different indices that are up there that are used for different things and different crops and different areas and everything. But these are kind of some of the ones that are used quite a bit. NDVI is one you've probably heard about. And the reason why it's called an index is because it's normalized is what's going on there. And you do that by subtracting the one on the top and adding on the bottom. And so that gives you a ratio from basically -1 to 1 is what you're looking at. So again, different indices are going to do different things. Again, it's all about visualization. So just because one says it's supposed to work for this doesn't mean that's the one you need to use. You need to take a look at several different ones. NDRE is basically the same as NDVI, except it uses red edge instead of red. That's typically later in the growing season. You're going to use that just because it will penetrate the red edge side will penetrate further for the to give you an idea about what's going on. A couple other ones down there I just threw in just to show you that there are some other strange ones in there. There's the optimized soil adjusted vegetation index. Again, all these are things that you can literally create the equation that I have written down there on the right, do whatever you want with it in order to make what you want it to pop. So there's lots of different options here. That's pretty neat. And then again, I'm going back to this one about the irrigation and erosion and that one again is huge in a lot of places. And just creating that digital surface model to be able to understand how the water is going to flow and where it's going to go is going to be a really big deal. So never forget that the DSM is kind of the place I always start with and go from there, because that can tell you an awful lot about what's going on. Again, irrigation, and now we get into the NDVIs, the NDREs, and we can see where they're having problems. And you go back to that DSM model and you go, well, you're having that problem because there's no irrigation in that that's getting to that area. So that never forget that DSM. It's always one to start with. So just to show you a few examples here, we'll start in the upper left. Again, these are all just made to make things pop out that you can see, and that's why the colors might be a little bit different here. The one in the upper left is that is a freshly planted Christmas tree farm up there, and you can see kind of the right half of that image. You can see the line of purple going down there with the yellow trees in the middle of it. Those trees are only about maybe 2 feet high or so, is about as big as those trees are. But you can see how on the right side of that image, there are specific areas that are void of any other vegetation where the trees are at. And as you move to the left side of that image, it gets a lot harder to identify that. Again, that's where we're seeing a lot of overgrowth. We're seeing a lot of weeds growing through there and other issues in those areas. So that's, again, an area where they're going to want to go take a look at possible irrigation issues and possibly invasive weeds that are growing up in that area. So that's the kind of thing, on that kind of small individual plant or tree area you can see. The next one, so the second one from the left and the bottom, those are mature trees. And you can see right in the middle, there's kind of the big C that's tipping up right there. And that's obviously a problem, because what you want to see are the trees like are down on the bottom left of that image, where you're seeing fairly consistent, I think this is at NDVI, of the tree there. And as you move up, you're starting to see that there's less and less as we go up there. So there's obviously an issue in this area. And we see with that tree with the C there, the center of the tree is basically dead, and a little bit on the outside is still alive. So what is causing that? Do we have an infestation there that's killing the tree from the inside, or what could that be? So those, again, are those kind of things that hopefully that farmer can see. They can go out and look at that area, and they can take care of a problem that might be happening right there. Again, an infestation or something, they can take care of something right there instead of waiting until they notice all the trees around there dying. The one in the middle top is kind of a fun one. Those look like they're little plants in there. Those are actually about 140-foot Douglas fir trees. So this is an example of forestry here. This is an indice that one of our students put together to try to show the difference between the areas where there were the deciduous or the harvestable, the conifers, the harvestable trees here, the Douglas fir in this case, and cedar, compared to the deciduous trees that aren't going to obviously be harvested for the same thing. So they built that, and with that and with AI, we can now count trees. We can measure the size of them with a using orthoplanes and things like that, so we can see the heights of the trees. We can determine how many are in, how many can be harvested in this area, if it's time to go harvest or not. And we can also pick up areas inside that might have some problems. So lots going on in that image. That's kind of neat. The student really made that pop, but again, that's what it's about. Now we know the difference. We can easily tell the deciduous trees from the others. And now again, we can run AI and other things like that with an image such as that. Okay, the second one from the right, that is just a near IR image. And what the farmer wanted on this one is to see whether or not the property was tiled. They were actually buying this property, and the owner said it was tiled. They wanted to see whether it was or not, and that can really change the growth of their, especially on a slanted field like this. But it's hard to see, but there are definite areas going north-south in this picture where you can see the tiles, and that basically confirmed that there was tiling in that area, which again is a big deal as far as the yield at the end of the year. And then the one on the far right is just a that digital surface model that I was talking about that is so important. The difference between just part way up, just not quite to the road on the south, but where that tree, where the highest part of the actual field is, that's about 5 meters higher than it is down at the far north part of that. So 5 meters is significant. And you can also see some of the rising terrain just before that T intersection in the middle upper part of the image, where it rises up about 1.5 meters above the area around it too. So those little things are really important to be able to get through. So those are some examples of some of the things with multispectral sensing you can do. Again, it's every field I've been to is different. They're going to want different things. The farmer has a different idea about what they're trying to get out of it. And you really got to listen, and you got to pay attention to what they're looking for. So again, some examples of the multispectral sensing. So let's start taking a look now at getting into some aerial application. And this is really an interesting area because for some reason, people immediately jump to the thought that if I do this and I don't have to have a pilot in the aircraft, it makes everything cheaper. And that may be true in some cases, but you got to be very careful about the use cases for this type of thing. For example, up here where I'm at, we have the large trees and everything. They harvested a forest not too long ago, about 100 acres. Helicopters came in. They did all the rest of the spraying, but they can't get up right next to the 150-foot trees that are right there. So drones were used to go around in the perimeter in order to finish it up and make sure that they had covered the entire area. Is it going to be cheaper to use drones on a 10,000 acre farm out somewhere in the Midwest? Yeah, probably not, because you're going to be out there all day for about 2 weeks in order to do something like that. Whereas a traditional crop duster / aerial applicator can get in there and do it very quickly. So a lot of times you got to take a look at that and say, really, is it cheaper? Keep in mind those initial costs we were talking about coming into this. The next one is it easier? Is it faster? And those type of things. It can be, and it might not be. Again, you got to take a look at the specific use case for that. Access is a big one, though, that I found, especially with the seeding in the late winter and early spring, where there's lots of runoff. The fields are very susceptible to ruts from tractors and things like that you really don't want to disturb. The ability to get into small areas and seed areas is huge. Terrain's another big one. Depending on how flat it is and what else is around there, it might make it economical and it might not. And then that last one is the precision, and that's really one that we can say absolutely that this is as far as precision goes, there's not much more precise than being able to go out, hover over a spot, and dump a load of something on top of what you're looking at. But again, keep in mind, you have the spraying drones like the one in the upper right, and you have the dispensing drones to be able to put granular down. And most of them can do both. You just a matter of having to change out the tank or the hoppers. Sometimes it's an easy process. On the one on the upper right, it was about probably about a 2-hour process to swap that out. So not something you want to do every day. Some of the new systems, you can literally just throw clamp off and pull them out. So there's definitely some good innovation going in there. But again, going into it, what are you trying to do with it? Is it really going to pencil out in the long run? Do you need it to pencil out in the long run? So there's lots of questions that need to be asked before you go out and try to do a lot of this. But the precise part of it is really the key to it. If you need precision, getting something in a certain area or on a small field, this is definitely a way to go with it. So let's talk about some flight planning here. This is a lot more complicated than you might think it would be, because if you take a look at that first bullet there, planning parameters, and you look at desired concentration. Sometimes, for example, on cranberry bogs up where I'm at, they will be putting some sort of fertilizer actually into the watering system. So now they're gonna flood the fields with thousands of gallons of water that's going to have a very low concentration of something in it. Well, if you're flying a drone, you're very limited on how much you can carry. So what is the maximum concentration you can carry without damaging the plants and still getting the effect that you want? And again, those are very difficult questions that you have to get the answers to, because you would love to put the ultimate, very concentrated load on something. But if you go out there and kill everything because you burnt it all with the fertilizer, you're really defeating the purpose of being there. So understanding the concentration that you can work with. Generally, more is better, but there's definitely a limit there. How high you want to fly is going to determine how far and how precise it's going to be. You get out to a field like is in the right, and now you weren't really planning on any wind, and now there's, say, a 5-knot wind, crosswind from right to left as you're going down the field. How does that affect your spray? Generally, the lower you are, the less it's going to affect it. The higher you are, the worse it's going to be. So how low are you going to be able to fly to get the pattern and get everything down on the ground like you want? Goes to say too with the lane width. So when you're creating this, how far apart are the lanes? What is the effective spraying distance of the drone? I probably want to go out and try to different altitudes. And again, the manufacturer will have a lot of this written down, but it's nice to go out and practice it with water and see how far the spray is going to go in different type of situations. Forward velocity is going to change the amount that's going to go down in a certain area. So the faster you fly, the less that's going to be put down in that area, along with how fast you're feeding it. So as you can see, there's a whole bunch of variables that go into this, trying to determine how much, or the parameters that you're going to put in to be able to go out and fly it. So it's not just something super simple, and it definitely takes some planning to figure out, especially when you're using different substances. There's clover seed in that one on the right, and in this case it was great because we literally went out there and flew at one patch and then looked to see what it was like on the ground, and then we actually ended up increasing the rate of it dispensing and kept the flight speed the same in order to get more down on the ground. So again, not the simple things you think about as far as collecting imagery or something like that. As far as the flight modes go, all these different aircraft basically have a automatic mode and a manual mode. The good news is that most of the manual modes are still they're mainly autonomous, in that you're just going to tell it where to go horizontally, and you're going to be able to set an altitude. So typically, with the aircraft we fly, we're flying between 1 meter to 1.5 meters above the ground most of the time when we're doing any spraying type of operations. That's kind of the sweet spot where we're going to be. Sometimes up at 2 meters, but most of the time down there low. All right, so there's also other modes, Manual Plus and things like that you can get into. When we get into the automated flight, there's all sorts of other things that go into that, all sorts of other programs that can be used, and very interesting trying to plan these missions in an effective way. So just to show you real quick, there are a couple different ways to get through this. DJI, as with everything else they do, they've thought it out well, and DJI is what we use for field management. It allows you to have field management, tell you what you put on what field, when you put it in there, what the concentration was, take notes about all the different fields and how you did it. It allows you to keep track of all the flights and everything else. So it really gives you quite a bit. This is down on that field I was just showing you, where we went out and did the first pass to see what the concentration was on that. So it gives you your flight, it gives you telemetry download and all that. There are some others out there. I think this comes from Helio. I think this is what their program is. Great U.S. manufacturer, by the way, of spraying drones. They have, again, a separate system they use, similar to what DJI has, very, very similar and effective program. And then you usually have some sort of also some sort of mobile apps. All right, so that was down and dirty on the multispectral sensor part and the spraying part. So let's get into the dreaded part, which is, yeah, the certification. So this is what you want to end up with. You want to end up with an exemption number from the FAA that says that, yeah, you can go do this. And you need to have an operating certificate that says that, yeah, you can do commercial agricultural operations. That's where you want to get to. And I'll give you the clue right from now. If you go to www.regulations.gov, go to the search site, jump in there, and you put in that search, that will call up the docket that Embry-Riddle has in there. And we'll explain how that works here in a minute, but that will get you to that. And the good part is that pretty much everything that's been put in there, all the requests and the waivers and all that, they're all part of public record. And you can dive in there and pull one up and go, okay, this is what we want to do. We're going to basically take this as a benchmark and we're going to turn that in for what we want to do. Now, the things that aren't in there are proprietary type things, flight manuals and that, and we'll talk about those here and again in a second. But if you just search that and go there, you're going to be pulled down our docket. You're going to see all the communications between Embry-Riddle and the FAA, and you can pull that down for any of the other dockets that are out there as well. When there's somebody who's flying something over 55 pounds that you want to know about, you can find one of those and you can dive in there and you can take their applications and stuff and use that as a benchmark for your own. So that's probably the key takeaway from this whole presentation is that you can go in there and do that. But there are other methods. So there is an easy button out there. There are some companies out there that will assist you on this. Some attorneys out there that will make that happen where that you can pay them some money and they will basically do as little or as much as you want them to do as far as waivers go, as far as manuals goes and everything else. Other companies, down, I think that one's from HSE is the one on the bottom where they will help you get your exemption package for over 55 pounds. So again, that easy button is great. The problem is that you're basically going to be stuck with the procedures and the manuals that they are giving you, because that's what the FAA is looking at for, especially the over 55 pounds. Is are you going to be able to do this safely? So you're going to be following somebody else's manuals. So anyway, just know there is an easy button. There are people out there that will do this and businesses that will make this happen. And we've been very, very, there's been some great products that they've put out and they've done just a fantastic job. So just realize there is the easy button involved in this if you want to go that way. All right, if you're not going to go that way, how does this process work? Kind of 3 steps to it. And as I mentioned in the start of this was up until August of 23, you had to go through the entire same process as you would be going through if you were going to go fly a R-44 spraying helicopter in order to get your Part 137, which meant you had to go through the Flight Standards District Office. You had to go get a check ride. They had to come inspect your area where you're going to be operating. They had to observe you doing the different things and everything. So it's literally an FAA certification, including a practical flight exam, if you will. They just changed that in August, so they no longer have to go through that. So that's what this is framing up as what you have to do now. So the first thing is going through, you have to petition for a waiver to paragraphs in 137 and Part 107. There's a bunch of them in 137, and then I think only one that I put down there for 107. But that's where that whole docket thing comes from, where you go into that, you make a comment to the docket. We'll talk about that here to get in a second, but you comment to the docket. That starts the process, and you put your exemption in there, and then the FAA will come back and they will start looking at that. Usually, they're actually pretty quick with it now. It's probably going to take maybe a month or two, maybe 3 months, but the timeline has shrunk down significantly from the almost year it took us the first time to get that waiver. If you are operating something over 55 pounds, before you petition for a waiver, because you're going to be operating actually under Part 91. So you have to get a Part 61 a waiver. You have to get waivers from some paragraphs in Part 91 and 137 as well. But the first step for that is applying for the N number. And that is a process where you go through. And by the way, there's some great stuff out there from the UAS office at the FAA. on how to do a lot of this. So they've really updated. The FAA has really stepped up here lately, and they've updated a lot of their pages, and they've made it so that the process that they talk about is actually the one you use. So anyway, you have to apply for that N number first. Once you get that, then you can, because this is over 55 pounds, the waivers are done per aircraft. Under 55 pounds now, the waiver they're going to clear you for is all aircraft under 55 pounds. If you're 55 and over, now it is going to be a specific aircraft. After that, after you get all that stuff done, then you're going to apply for your operating certificate through the UAS Part 137 office. So in pictures here, this is that regulations.gov. You're going to go to that FAA 2007-0101, and you are going to find where that arrow's pointed right there, which is how to do it. Take a look at that. But the bottom line is you're going to write a comment. You're going to put in there what you want to do. You're going to put in your documentation. You're going to give them communications and how to get to you. And what they're going to end up doing out of that is giving you a docket number. And that's where that, remember that search thing I gave you earlier, the FAA 2022-00 or 0339. That's the Embry-Riddle docket. They're going to assign a docket number to you, and that's where the future correspondence are going to happen through that docket. That's the public record part of what's going on with this. Once you get that waiver, or your authorization for 55 and over, then you're going to email. This is the change. Now, instead of going through the FSDO office, you email the UAS 137 certificate shop at the FAA, and they're the ones that are going to take care of that. And again, great shop, great people. They're doing some great work, and it is so much easier than it used to be. So it's really worked out well. But let's take a look at what you're signing up for. The process is much easier, but what goes into the process is not. So the COA details, things you have to have: operator's operation manual. You have to have a training program. Obviously, you're following the flight manuals, but then you have to have all the other manufacturers' UAS documents and everything else with you, and you have to have this exemption. So just the fact you have to have an operations manual and you have to have a training program are significant, because that now means you have to have records of all that too. What else is in here? The operations manual itself has to have all this stuff in there. Keep in mind, it has safety risk management in there. What's your safety program? You have to have all this in your manual as far as how you're going through this. How are you going to do CRM? You have visual observers. How are you going to do that? How are you going to do your hazmat handling and storage? That has to be in that operator's manual. Then you get into the training program. These are the things that have to be in your training program that you have to be able to document and say that you've done. So this is why somebody's getting paid $2,000 to $3,000 to do this for you, is because they have these manuals that they will allow you to use for those prices. Otherwise, you're creating this yourself. So what does that really mean? So this is how we run our shop, and fortunately, because of the AUVSI Trusted Operator Program as a training provider, we are required to do all this stuff anyway because of that. So for us, this was really easy because we already had it all. But for example, you have to have that flight operations manual. You have to have a way to track the documents in that for all the different things you're doing. You need to have some sort of a manual for the aircraft. This is ours for the our standard operating procedures for the MG-1P. Then you have to get into maintenance. How are you going to handle maintenance? Because there's requirements for that. Who can do what with the aircraft? It mentioned you have to do safety risk assessment. You don't necessarily have to have an SMS, but here's our SMS that goes along with that. What about how you're doing all of your training for this and everything? We use the top system, where we have our check rides and everything we do through that. What about academics? How are you going to teach that? We have our academics that we do, where we keep track of who's gone through it and all the academics that they have. So we have the ability to track all that. And then how do you track who's qualified for what? So we use these forms in order to track our pilots and what they are able to be qualified to go do. So just because you can go in there and the FAA has streamlined the ability to get the waiver, it doesn't, or the certification, it doesn't mean that they've changed what's required for you as the operators to be able to have in order to be able to do this. So that's kind of another big takeaway is, yeah, you can get the certification, but if something goes wrong, I should say when something goes wrong, because it will, and now you're backtracking, trying to show the FAA, the NTSB, the attorney, or whoever it might be, that you had your act together and you now have a waiver and that says that you can do that, you're going to do all these things, and you don't have your documentation together, guess what? it's now gross negligence. So they've eased it up for the requirements to get there, but getting there is still difficult to do. So I'm running out of time here, so I'm just going to jump into this today. Yeah, we've covered a lot today. We talked about some of the initial stuff. We talked about sensors. We talked about some of the products you get with multispectral sensor. We talked about spreading and doing all that stuff. And then the end part of that, we've obviously hit on some of the operating certificate and how to obtain that. So I would be remiss if I didn't just throw up, at Embry-Riddle, all we do is aviation and aerospace and everything. The biggest and largest have been around for a long time. In our professional education side of things, we have a bunch of courses available. As far as the drone side goes, there will be another edition here shortly, which will be some agricultural operations. But you can see we have an awful lot in there. We've just, because of our work with some of the government agencies, we now have flight training on there as well, multi-rotor basic and advanced. In that advanced class, you'll actually do a project using multispectral sensors and all that, and a fixed wing advanced course as well. So I know I talk fast. There's lots of material there, though. Hopefully we generated some questions. So Shannon, you got any questions out there that we can dive into?
We certainly do. They are rolling in. All right, so I'm going to jump in, but as a reminder to our attendees, go ahead and use that Q&A button at the bottom if you have a question that you would like to submit. All right, so first question, do you think that these aerial applications will be like completely taken over by drones? And if so, when?
It's going to be a long time before that happens. And again, it comes down to just the economy of scale on a lot of this. You're very limited on what you can carry with a drone compared to what you can carry with a helicopter or a fixed wing aircraft. And although there are large aircraft now, or larger aircraft that can carry 200 gallons or so of whatever you might be applying, it's still not as, in my opinion, it's not as efficient. And I don't think it'd pencil out either, as it would be able to call the local application folks and have them be able to come out and do something quickly, because it's just the ability to cover a large area with the drones just isn't there. So there are very specific cases. What I can see is a lot of the companies out there that are currently doing aerial application, they can bring drones on as an additional part of what they can do. But I definitely don't see it completely taking over. I guess the conversation is that'll probably take over about the same time as we get on an airplane, going to Hawaii and there's no pilot on it. That'll probably be about the same time that happens.
Fair enough. So eventually, but not yet.
Yeah.
Another question that came in asked if there was any transition into BVLOS operations in this industry.
Yeah, that's a really good question, and there is. And interestingly, down in Texas, Dr. Scott Burgess was part of an assure test with the FAA where we flew a fixed wing drone off of a runway there, and we were flying helicopters up to determine basically right away what kind of maneuvers a drone needs to do to maintain safe separation and things like that when an aircraft comes into the area that does not have ADS-B and things like that. So anyway, it was very interesting, and that goes into the BVLOS part of this. As you probably know, the BVLOS, there's a lot more waivers going out there now, a lot more capabilities, especially anything below 50 feet. The FAA is allowing BVLOS operations now with the correct, obviously, waivers and everything, staying down low for like pipeline inspections and things like that. It's definitely something that's getting close. But for the most part, these aircraft are fairly large. You can see them out basically past a mile from what I've seen, with the size of them and their spraying and everything. So while BVLOS is very important in a lot of areas, in the smaller, what I think that these drones are going to be flying in order to do the job, I don't know if BVLOS is really as important as the swarming side of it. So the ability, and the FAA has given waivers to this too. the ability to go out there now and fly 5 drones with 1 pilot and be able to do an entire field with 5 aircraft. And that's a little bit of a game changer. And that side of it, I think right now is the more important side than the BB loss.
That's a perfect segue because we had a question that came in on just that topic. If there was swarm technology solutions and having, multiple drones to tackle like one area altogether. So it sounds like yes.
Absolutely, there are, and that's being done. One of our other partners that we work with very closely is Warren County Community College up in New Jersey, and I believe they just received their a waiver to be able to do. I think it's up to 3 aircraft with 1 pilot. So that is going out, and I know some of the other bigger companies that I won't mention their name, but they are flying several drones with 1 operator. So that is going on, and it's definitely you talk about again economy of scale and being able to deliver to a larger area, and that's definitely where it needs to go.
Perfect. Thank you. Going back to the conditions and limitations piece, we had a question come in that asked if you could cover the conditions and limitations that you feel are being missed by the industry, if any.
Okay, cover the what, the conditions and the say it again.
Limitations. Can you cover the conditions and limitations that you feel are being missed by the industry?
Well, I guess the question is what industry, I guess would be the question, because this has happened throughout the UAS world. Is that so? I've been involved in aviation for the last 40 years, and there's things like RID that come up that is like, well, of course, in an aircraft we're going to squawk, but half of the UAS community is up in arms about it. So there's a lot of things on the aviation side that is the way it is, and we've been dealing with that for a long time. And when you move it over to the UAS side, there's a lot of people that don't understand why we do it that way. Well, there's reasons why, and there's usually blood involved. So it's one of those that if you look at the industry of the UAS industry on that side of it, I think the big thing that is missing is what we call at Embry-Riddle professional aviation. That's what we teach. And you'll see that happen every day when are there procedures? Are people following the procedures that they said they were in their operations manual? Are they using checklists? Are they doing a risk assessment when they get to the area? Those pieces of the UAS industry, I think, are grossly missing, which is why we were initially an early adopter for the trusted operator program that AUVSI has, because that brings professional aviation into the UAS world. As far as the other side of that, if you look at the aerial application world, for example, there's kind of 2 attitudes out there. There's a lot of the current operations out there that don't want anything to do with drones. They want absolutely nothing to do with it. And they see it as the drones taking over their business. And I think that's fairly nearsighted, because a drone cannot do what an egg cat can do. They just can't. Until we can have an egg cat drone, right? So on that side, there's that side, and then there's the other ones that they're leaning forward a little bit more, which they bring them into the hangar and use those to augment the other kind of spraying that they're doing, because now it opens up a lot of the smaller farms. Because now you think of a small farm that might be, let's call a small farm 100 acres. You have a 100-acre farm that might be doing something that might not be using regular aerial applicators, but now if there's a drone available, they might be able to use that. So a lot of these companies can branch out into that, is from what we're seeing. So I'm not really sure if I answered that question. That's kind of from the UAS industry and from the aerial application industry.
No, thank you for that. That's perfect. A question going back to Embry-Riddle and offerings. So are there professional education courses at Embry-Riddle offered through continuing education, or do you have to be a degree seeking student?
Yeah, that's a fun question for me to answer, because in the past, in order to do any flight train or anything like that, you had to be in the degree programs. And on the UAS side, we no longer do. So in effect, if I go back a slide here, if I call up this, these are all classes that are currently available that we have through our Office of Professional Education, and most of them are priced at about $399. So, for example, some of our popular classes, this photogrammetry class using Pix4D is just fantastic. So we have a lot of courses that we offer. We even offer someone here for public safety. We worked with the folks down at the Daytona Beach Police Department very early on back in 2016 and helped them go through their entire program and get them all set up. So we do an awful lot. We also do the Airborne Public Safety Association. We're partners with them, and we do their certification as well through some of our programs. And then, just our flight courses as well, like I mentioned earlier. Those flight courses are really good. They're not your standard, hey, this is how you go fly a drone. It's teaching the professional aviation from the mission planning, how you go through all that, to tracking, to the telemetry, to safety, to risk management, and going through those whole things. So those flight courses are a lot more than just learning how to fly an aircraft. They're an introduction to a professional aviation and how to do it right. Because what we find, just on a sidebar, with our students that go through, especially our adult learners. So we have a lot of adult learners that go through our education program that are coming out of the military, and almost to the T, they say that the reason they're getting a job, for example, some of the big interesting places to work now, Zipline, for example, is because they understand professional aviation and they understand the safety process. And that's the part that I always tell people who are trying to get into this industry is you have to understand aviation and professional aviation before you really can get anywhere. Because without that part of it and understanding how safety works and understanding safety management systems, what risk assessment is, all those type of things, you're really missing out on a lot of the possibilities. So yes, the answer is yes. We have a lot.
Awesome. Great. That's perfect. Thank you. We have had a lot of questions come in, and I'm watching the time. I don't think we'll get to all of them, but rest assured, if you submitted a question that isn't answered today, it's going to be provided, and there will be some follow-up after the fact. So moving right along, another question that came in asked, how much autonomy of the drones is involved here, like human machine control and decision making?
It totally depends on the aircraft and the software that you're using. For the most part, it is I don't want to say if you're doing it right, but if you're using the capabilities of the aircraft, the majority of what you're doing are automated routes. So there is quite a bit of automation involved in it. So, but like I mentioned, the very first slide there with those trees out there, there's always something that you go out there, there's something different. So for example, you can plan the field on the computer, but you're talking about maybe being within about maybe 7 to 8 feet of accuracy on that. Because you're talking about using RTK systems and things like that, you need to be accurate. So if you're talking about trying to spray around a tree out in the middle of an area, you want to be more accurate than that. So typically there'll be flight planning involved at the area, whether that's flying the aircraft over the different points and selecting waypoints that way, and then allowing it to build a grid. Just depends. And so typically, if a typical scenario, I'll go out, I'll have a planned area I'm going out to. I will either fly the aircraft or I will walk the field and mark the points. And then I'll also identify where the obstacles are at. And that's a point that can take quite a bit of time. And then I will tell what I want it to do, how much I want on the ground, what the concentration is, and the system will pretty much tell you about what its plan is. And then you can adjust those parameters as you see fit too. If you want to fly faster and put out more, you can do that. You can choose economy and efficiency, those type of things you can do. So yeah, if you've ever done many missions with Pix 40 capture type thing and drone deploy and things like that, where you're flying grid missions, it's very similar to that. The big difference though is you're a dang meter off the ground. So you got to have your act together.
That's very true. Okay, so we might have time for one, maybe two more questions, but looking at the impact that this technology can have in the agricultural world, going back to your clover example from the beginning, did you see a high success rate when seeding the clover with your drone? And just our attendee was wondering how well the seeds take without incorporating them into the soil.
Yeah, that's a great question. If you're driving a tractor out there, it's going to be different. They can have different velocities as it goes down in there and things like that. You're going to end up doing a lot of overseeding, with this. Obviously it needs to be falling down there on the get to the dirt. Up here, fortunately, the thing that we have going for us is as we get quite a bit of rain up here, So it rained about 2 days later. And so any of the seed that might not have made it down to the soil is now in the soil and down there low like that. So we see very good results. We did one big test last year. And we had very good success on it. Again, I would say that we probably overseeded in that area to get that success. But again, the ease of doing this and not driving the tractor through the fields completely made up for the cost of that additional seed. That's a great question.
All right, perfect. Well, it may be the one that we have to end on since we are right at the top of the hour, but I do want to give you a chance to offer any closing remarks or kind of final thoughts before we close out for the day.
Yeah, I mean, this is just an exciting area, and the Department of Flight at the Worldwide Campus, we just love doing different things like this. We love going out and learning. You can see the pictures right there. We're actually hiding in the trees there with actually some folks from the Department of Justice that are doing some Overwatch things. We're down there in that next picture down below. We're out doing Overwatch of active shooter areas at nighttime with IR cameras and stuff. It's just such a great industry because with my attention span being about 15 minutes, it allows me to jump around to a lot of different things. And this area of going from multispectral sensors into seeding and spraying and everything and learning all that, it's just fascinating. There's always something new to learn, and you always feel like you don't know what you're doing just because there's so much out there. So yeah, it's just fantastic, and this has really opened it up with what the FAA's done. So hopefully we'll get a lot more folks out there starting to do this.
Absolutely. And thank you for this information. I know it's been super valuable and couldn't agree more about the interest of this industry. So on behalf of AUVSI, thank you, Dr. 30acre, for this excellent presentation, this great discussion today, and to Embry-Riddle for their support of this webinar. So attendees, I mentioned in the beginning, you will receive a link to access this webinar recording along with a copy of the slides within the next few days. So another exciting feature is all of our webinar recordings are available on AUVSI's learning and engagement platform, AVL. So I encourage you to look around when you go in to view this recording. So if you have any additional questions or comments for our team, please feel free to email us at education@auvsi.org. And lastly, today's program is copyrighted by AUVSI with all rights reserved. So thank you again for joining us today, and we hope you have a wonderful afternoon.